Today we're talking exhaust manifolds. They need to do two things. They need to flow exhaust and they need to withstand extreme temperatures. We're going to talk to you a little bit about what we do to get that. A couple things we do is we cast them here in Canada. We make them out of high silicon ductile iron. It's able to withstand higher temperatures and increase that durability, and we make them thicker than stock. That gives them the durability you guys need. Another thing you might notice on our Cummins manifolds are slip joints. And what actually happens is as a motor heats up and cools down, the motor itself actually expands and contracts. The same thing happens to the manifold. You can see this from stress cracks in a manifold as well as broken studs. What the slip joint does is it allows the manifold to move and it relieves this additional thermal stress. As you can see here, this slip joint allows the manifold to move with that expansion and contraction. That gives you a more durable manifold. It reduces the stress cracks and prevents studs from breaking. Speaking of durability, have you ever driven a new Ford? Boom, new 6.7 Ford manifold. On the stock one, the biggest thing that fails is actually the stud. This little guy right here. When they break on a stock manifold, you'll notice this by an exhaust leak around the manifold itself. And what's happened is that stud is no longer able to hold the manifold to the head. So what did we do? We changed the machining and we made a taller stud and spacer. We include 16 new nuts, studs, and spacers, as well as increase the machining height on the manifold itself. And what this does is it actually gives that stud a little more room to stretch as the thermal cycles come through, as the engine gets hot and cools down. And what that does is you actually see a lower stress in that stud. So with this lower stress, it gives a longer lifespan. The next thing you care about is exhaust flow. So what we do is, as you can see here, we cast them specifically for your application. Some manufacturers cast one piece and then machine this differently to fit different options. They'll do this whether it's a motorhome, a bus, your truck, any of them. We have specific castings for your application. In front of us here, we actually have the common rail 24 valve casting or the 12 valve casting. The other interesting one is our port match high flow T6. And so a little bit of the differences on these guys, these are specifically cast to be port matched. On our high flow guys, in case someone ports the head, we actually gasket match on our high flow T6. As you know, there's different kinds of inlets and different kinds of outlets. These are set based on the turbo you have or your application. It's between those two ports where the magic actually happens. How do you get an exhaust manifold to flow? Well, you have to know what flows well. You avoid sharp bends, tight corners, bottlenecking where the flow kind of necks down, opens back up. We can do this, we draw it in a computer. This allows us to simulate it in CFD, computational fluid dynamics, and this allows us to optimize everything before we even cast the first part. Once we have the cast part and we machine it, we can test it and verify, make sure everything works for you. If you have one of these in person, one thing you can take a look at and focus on is you can see how smooth the transitions are between your inlet to your outlet. And just remember, it is actually flowing into a turbine housing, so the flow doesn't stop here. Remember, we're talking about exhaust manifolds for turbocharged engines. What do I mean by that? It's just as important to get the exhaust out of the engine as it is to get into the turbo. So you may have heard of the term pulse manifold. What does this mean? In a 6-cylinder diesel engine, while one exhaust valve is opening, another one is closing, two can be open at the same time. So you might have an exhaust pulse coming out of the cylinder, bouncing around to the manifold, averaging itself out, and then eventually slumbering its way through the turbocharger. In our pulse manifold 2-piece or our 3-piece, we fully divide the front 3 cylinders versus the back 3 cylinders. And this allows you to maximize the initial impulse as that valve opens up, that high velocity pulse straight to the turbo. The next part is actually the turbo. We want to capitalize on when that exhaust valve opens, there's a high pressure pulse. We want to send it straight to the turbo, nice smooth transitions. We don't want it bouncing around in a log manifold, kind of making its way, eventually averaging out. We want to send it directly to the turbo, and we want to send it now. So what does all this mean? We do the extra work for you. We make specific castings, T3, T4, wastegate ports. We've drawn it into the computer, optimized the flow. We have different machining processes that improve it over stock. We have everything you need to make sure your manifold doesn't fail. Designed here, built here, perfected here, bddiesel.com.